Now for the same problem we have seen, let's solve assuming that it is a preemptive priority based scheduling algorithm. Okay, for the same table we are assuming, so far we have solved, we have thought that it is non-preemptive priority based scheduling algorithm. Now let's assume that it is a preemptive priority based scheduling algorithm and let's solve it. Okay, so our Gantt chart as usual will start with time unit 0, and at time unit 0 the only process which has arrived to the RAM is P1. So P1 will be scheduled, and P1 will and P1 should execute for at least one time unit, right? For at least one time unit. Why? Because at time unit 1 P2 arrives to the RAM, and so this becomes 7, and P2's priority is higher than that of P1. Why? Because 8 is greater than 6. Okay, so P2 will be scheduled and it will execute for at least one time unit, so it will become 5. Fine. Now the highest priority, which means the process with the highest priority arrives to the RAM, which means in case if the process with the highest priority comes to the RAM, then it will execute in one go, right? Because even if we execute after one, even if we see after one time unit or two time unit, this process will have the highest priority always, right? So we will continue with process P3 and then we will complete it for 4 time units. Okay, which means P3 will run till 6 time units. Fine. Now P3 is done. Now from till 6 every process has arrived, right? Every process has arrived. Fine. Yes, every process has arrived. Now among these three, P3 is done. Okay. Now among these 5 processes, the process with the highest priority is P6, and so P6 will continue. Okay. Now let's see one important point. In preemptive priority based scheduling algorithm, whenever all the processes has arrived to the RAM, from that point onwards, our preemptive priority based scheduling algorithm will behave exactly like non-preemptive priority based scheduling algorithm. See, at time unit 6, every process has arrived to the RAM, right? Arrival time, all the processes has arrived to the RAM. From now on, this preemptive priority based scheduling algorithm will behave exactly like non-preemptive priority based scheduling algorithm. Okay, it is very important. Fine. Now at time unit 6, we will start with P6 and then we will continue it. We will complete it. Why? Because this has the highest priority, right? Now even if it run for one time unit, this 3 will become 2. Still, this has the highest priority, so we might have to continue with this. And even if you decrease it one, if you run it for one more time unit, this 2 will become 3 has become 2 and 2 will become 1. Again, this has the highest priority and we might have to continue with it. See, that's why I told that our preemptive priority based scheduling algorithm will start behaving like non-preemptive priority based scheduling algorithm from the point at which every process has arrived to the RAM. Okay, now at time unit 6 every process has arrived to the RAM, right, at only at time unit 6. So from now on it will behave, which means the preemptive priority based scheduling algorithm will behave exactly like non-preemptive priority based scheduling algorithm. Fine. Now let's run P6. P6 runs for 3 time units, right? It will run till 9. Fine. Now this is done. Now we need to execute this, right? P4. So P4 will run till 11. Okay. So P4 is also done. Now we will go with P5, right? So P5 will run till 21 because it needs 10 time units. Fine. So this is also done. Now among P1 and P2, P2 has the highest priority. So P2 will run till 26. Okay. Fine. So this has become 0. Now we have only P1, and P1 will run for 7 time units, and so it will run till 33. Okay. This will also become 0. That's it. Okay. This is all about preemptive priority based scheduling algorithm. Fine.